right, guys, I'm going to call out this number, and you're going to look at that net. A net is when you take a 3D solid and you crush it down to two-dimensional, actually. You make it flat, and that net is what would build up and create your 3D solid. So, number 1, what kind of 3D solid is that? Number 1. Toby's looking alive. Thank you. Oh, it was number 1 here. Triangular prism. 2 triangles, 3 rectangles. It is a prism, and we'll talk more about that in a moment. Number 2. Good. And the way you say that is trapezoidal prism. Number 2 is a prism as well. We'll talk about what prisms have in common. Number 3. Number 3, the way to say that one is pentagonal prism. Not pentagonal, but pentagonal. Okay, number 4. Good, we're switching gears a little bit. Number 4 is not a prism. It's a triangular pyramid. Number 5, easiest one, right? It doesn't have 2 words. It's the only one that doesn't have 2 words. It is a cylinder. What about number 6? Is that a cube? No. Yes, it's a rectangular prism. Number 7. So you can't assume it's a square. I agree. But you do have multiple choice, and only one of them can fit. So we're going to do square pyramid. I guess they're implying that it was a square. You can't assume, but a square is a rectangle, so it's also a rectangular pyramid. And number 8, how do you say that one? Hexagonal, kind of like pentagonal. Hexagonal prism. Okay, let's look at all of the prisms. What do all of the prisms have in common? It's kind of hard to talk about what they have in common when we haven't talked vocab yet. Their lateral faces are all rectangles. You said it. There's a lot of rectangles in a prism. And how many bases do prisms have? 2. Yep. 2 bases. What about pyramids? What are the lateral faces of a pyramid? 1 base, yep. And the lateral faces, when you unfold it, are all triangles. Very good. Before I use that vocab too much, let's make sure that we know what our vocabulary is for this unit. I'm going to call on people. These words are the foundation of our unit. Know the words, understand the words, be able to say the words automatically when you see a shape. So, I want to talk about the shaded ones first. If you're given a prism and you don't know which side is the base, we will shade the base for you. So the base will be the shaded ones. A prism always has 2 bases. So these shaded regions are our base. The base can be anything it wants to be. It has to be a polygon. The base can be any polygon it wants to be. The lateral faces, on the other hand, so this is a face. A base is a face, by the way. Base face, sounds weird. Those are the base faces, and those are the lateral faces. The lateral faces cannot be anything they want to be. In a prism, the lateral faces have to be rectangles. So the bases can be whatever they want. The lateral faces have to be rectangles or squares, but squares are rectangle. A vertex is where your segments meet up, and an edge is where your faces meet up. So when a face meets a face, you get an edge. Now, one of those edges is the height of your figure. Which edge would be the height of your prism? The lateral edge or the base edge? Yeah, and we'll talk about that more as well. So the height of your prism is whatever edge connects the base to the base. So if I fold this back up, here's my bases. How tall are you? Well, it's not this tall. That's not how tall it is. It's this tall. So it's the segment connecting the 2 bases. All right, let's do some riddles. How tall are you? You answered me. Okay. I have exactly 1 base and 3 lateral faces. Okay, so we gave it away right there. I have one base. Well, it's not a prism because prisms have two bases. So if I have one base and three lateral faces, I am a pyramid. If there's only three lateral faces, then that means the base has three sides, and so we've got triangular pyramid. Next riddle. Each one of my lateral faces is a rectangle, yet my bases are not. I only have 6 vertices. So let's dissect this. Lateral faces are rectangles. All right. So we're automatically a prism right here. And it only has 6 vertices. That's not very many. Vertice is every corner of your shape. Not my base has 6 vertices. The entire solid has 6 vertices. So that means you can give 3 to one base and 3 to the other. Well, if each of them only have 3, then you've got a triangular prism on your hands. Yep. I have more edges than the other solids on this page. More edges than any other solid on this page. Good. How many edges does a hexagonal prism have? Woo! 36. So we've got 6 here. I just said 6 times 3 was 36. Wow. We've got 6 here, 6 here, 6 here, so there's our 18. There's our 18. It's still a lot, 18 edges. Okay, next one. My base is a circle, and I have 2 heights, one that slants and one that does not. Good. So when you saw that the base was a circle, you knew it was a cylinder or a cone, but then when you saw it had 2 heights, a cylinder only has 1 height. So it had to be cone. Yep. We'll talk about this on Friday. I think we won't get till Friday. But that's its height. And then that distance, the distance from A to B here, is called a slant height. Slant. If you drew my net, it would consist of 3 shapes, a rectangle and 2 circles. Do you ever think of a cylinder as having a rectangle as part of it? Yeah? So a cylinder is a rectangle. It's not a curved rectangle. It is a true rectangle with a length and a width and then 2 circles. But when you fold it together, you get a nice, beautiful cylinder. But a cylinder is made of a polygon, a rectangle, and then circles are not polygons. So it's made of 1 polygon and 2 circles. I am very interesting because each pair of my opposite sides is parallel and congruent. Therefore, any one of my sides could be considered my base. Yes, no, Alex got it. No, actually, no, you're right. I'm looking at my choices now. Rectangular prism is the answer. Even though this is not a cube, it didn't have to be a cube. It didn't say all of its faces were congruent. But it did say any one of its sides could have been its base. Any one of its sides could have been, not its sides, its faces could have been its base. So when you have a rectangular, this is a cube though, when you have a rectangular prism, you don't know which one the base is, so we have to shade the base for you because you don't know automatically what the base is. Now, if it's a triangular prism, the base is whatever there's 2 of. It would be the triangles. All right, so let's begin our lesson. We're going to focus on prisms and cylinders today. Prisms and cylinders. So let's start with prisms. Here's lots of real-world examples of prisms. A lot of times the pencil you use, if it's not, well, even if it is mechanical sometimes, a lot of times it's a hexagonal prism. We've got a tint, triangular prism. Tons of buildings are prisms. Presents, any sort of box, tissue box, all good prisms. You may write down the definition of a prism. To be categorized as a prism, it has to be a solid. So right there it means it needs to be 3D. No flat prisms here. It has to have a pair of bases. That means a prism has always 2 bases. Always, sometimes, never. Always. The bases have to be congruent. There can't be one that's bigger than the other. There can't be one that has a different shape than the other. And the bases have to be parallel to one another. So they really need to be in parallel planes. If they're not in parallel planes, it's a solid, but it's not a prism. So to be a prism, the bases need to be parallel. So if I had this prism, but this one was kind of slanted like this, and I connected them, wouldn't be a prism. Its lateral faces would probably have to be like trapezoids. They wouldn't be rectangles. Or they'd be slanted. They would not be perpendicular to the base. I wanted you to write down this page, but I don't want you to write down any more pages. You hear me? You can watch, you can listen, but don't write it down. You don't need it. Okay. Lateral face is a really fancy way of saying the rectangles. So the rectangles are our lateral faces. They simply join a base to a base. Don't want you to write it down. So in a prism, the lateral faces are always rectangles, and they join a base to a base. The lateral edges, a really easy term for this is, our height. So the lateral edges, I'm going to reveal them. They kind of turn like reddish purple. Do you see that? The lateral edge, no, it's pink. It looks pink on the screen. Those are the height of your prism. So whatever edge connects your base 1 to base 2, that edge is your height. Even if your prism's like this, even if it's like this is not the height of the prism. The height of the prism connects your base to your base. Your bases are, of course, the pair, that means 2, congruent, non-negotiable, and they need to be parallel. So I want you to keep in mind that your solid will not always be sitting on its base. The most common mistake that I see is that people solve this one right here. They plug numbers into the formula that's given to you, but they use this rectangle as the base of the prism, and they get every answer wrong. Because that rectangle is not the base. The prism will not always be sitting on its base. The base is whatever there's 2 of. I know, facepalm, right? The base is whatever there's 2 of. Whatever there's 2. Got it? That's the base. And you name the figure based on its base, right? So if there's 2 pentagons, it's a pentagonal prism. If there's 2 triangles, then it's a triangular prism. We already talked about that. The height is the length of the lateral edge. It's the segment that connects the base to the base. All of the prisms we study are going to be right prisms. So if you see on your homework, find the volume of a right hexagonal prism, and you're like, what does that mean? It just means it's standing up straight. So we're not going to study the Leaning Tower of Pisa. They're all going to have good posture, so they're all going to be right prisms. The only big difference is when it's oblique, is that kind of like an obtuse triangle, the height falls outside of the figure. So, sorry, we're not going to study those in this class. Okay, do not type this yet. Please look at both examples and determine what the height of the prism is. The height of the prism, but do not type it. The height of the prism. You weren't fooled. Very good job. So, the height is not 7. It's not 5. It's not the height of the pentagon. The height is the segment that connects the base to the base. The height is 9. Even though it's laying on top of 9, that is the height. In this one, the height connects the base to the base. So the height is 12. It's formula time. You are going to be given 3 formulas. One of them is called LA, the other one is SA, and the last one is V. So lateral surface area, and volume. Okay, so in a prism, the lateral surface area is just the sum of all the rectangles, the area of the rectangles. The lateral surface area means I want to paint the whole prism except the bases. So when you paint the walls of your home, you usually don't paint them the same color as your ceiling. So when you paint the walls, You're painting the lateral surface area of your home. When you put a soup label on a soup can, you are covering the lateral surface area. You're not covering the bases. So that's lateral, that's LA. SA, it's kind of weird. When you see SA, it really means total surface area. We don't call it TSA. It's not airport security, but it's total surface area. So when you say SA, find the area of all of the surfaces, which you'll be given a formula for. And then good old volume. Volume is when we go 3D. So this is, by the way, this is 2D. This is 2D, and here's where we enter the third dimension. How many cubic units are in this figure? Not square units, but cubic units. Think of volume as you're filling it, Here are your formulas. You can write them in your notes, but if you keep a formula chart right by you at all times, then you don't need to write these in your notes because they are contained on your formula chart. Formulas are no good to us if we don't know what the variables mean. We need to know what the variables mean. Very cool, Alex. Capital P, it means something. It stands for something. It stands for perimeter, but not just any perimeter. Perimeter of the base. Not the perimeter of both bases, the perimeter of one base. So capital P would be add up the edges of the hexagon, or add up the edges of the triangle. Perimeter stands for, P stands for perimeter of the base. H is the height of the prism. And we already practiced finding that. And then we need to define capital B. By the way, when a variable is capitalized for these purposes, it's talking about the base. So capital P, perimeter of the base. Capital B, area of the base. So when you have to find capital B, here and here, you're really doing last unit. You have to infuse and embed last unit into this unit. So if the base is a trapezoid, you have to go to your formula chart, and capital B is really this long formula. So there's like a formula inside a formula. So be careful there. Capital B means area of the base. Sometimes it'll be easy, it'll be a rectangle, and sometimes it'll be a polygon. And you'll have to do apothem times perimeter divided by 2. Good. Okay. Let's do an example where we're actually finding P, H, L, A, B, S, A, and V. It's a lot of letters. Go ahead and put this in your notes. Find all 6 values, and then we will compare. Yet, what is the perimeter of the base? What is capital B? Capital P. What'd you get, Hatham? 48. Very good. So there was a little bit of a trick ingrained here, right? We know our base is the triangle. In a prism, the base is whatever there's 2 of. And to find the perimeter of the triangle, there's no trick. You just add up the sides. But we were missing a side, so we employed what? We employed Pythagorean theorem. And we found that the missing side was 16, because Ms. Tanton is so nice to us and made it a Pythagorean triple and not a radical. You're welcome. The height of our prism is whatever segment connects our base to our base. So we are lucky our height is a nice pretty 10. Sharon, what did you get for the lateral surface area? Very good. The lateral surface area is 480 centimeters squared. It just says P times H. So you found your P, you found your H, you multiply them. You don't have to show work there. Once you have P, H, and B, once you have these values, I recommend you do everything else in your calculator. No need to write it down. What was the area of that base, Asha? Nice, 96. So to find the area of the base, you're using last unit, 2D figures. So this is a 2D figure, and its formula is base times height divided by 2. So we had to plug in 16 times 12 divided by 2. Do you see how this could get confusing? I want you to stop and listen real quick. I have a lot of students get confused with the height of the prism, which is 10, and the height of the base, which is 12 or 16, whichever one you want. Do you see how there's two h's in this problem? But one of the heights is inside the formula for base, and one of the heights just stands alone is the height of the prism. So don't get confused about there being multiple heights within a problem. 6 times 12, don't forget to divide by 2. You forget to divide by 2 and it'll affect the rest of your answers. 96 centimeters squared. Thank you. The surface area is 672. The formula is pH plus 2B. You guys are not allowed to reinvent wheels. Do not reinvent a wheel that's already invented. So pH, this is just the lateral surface area. You've already found that. You've already done the hard work to find that, and you've already found B. So when you go to find the total surface area, please don't multiply P times H again, because that leaves you a room for error. Make sure you just take the lateral surface area, and then what are you missing when you have the lateral surface area? You're missing the bases. There's 2 of them, so that's why it says plus 2B. Or not to be. Or to be. Anyways, so please use ones that you have already found. Use them. Last one is volume. Volume goes to Emily. Thank you, Emily. That's perfect. 960 centimeters cubed, or cubic centimeters. I love volume. Volume is my favorite because it's so simple. Area of the base times the height. Area of the base times the height. I love the simplicity of the formula. Let's do a real-world problem real quick. An aquarium owner has 200,000 gallons of water, which sounds like a lot, but when you're filling an aquarium, not so much. What percentage of the fish tank can she fill? You own an aquarium, probably not this big. Okay, your aquarium has alligators. So what would we need to compute to start this problem? When you're filling something with water, what are you finding? Go ahead, type it. The volume is 55 times 115 times 10. Whoa. Okay, 63,250. That's how many cubic feet it is, though. 6. I don't want my answer in cubic feet. I want my answer in gallons. So what do I do next? Times 7.48. Very good. Times 7.48. And we have a nice large number in our calculator. That's our denominator. 473,110. And she only has 200,000 gallons of water. I hope those fish are going to be okay. It says what percentage would she fill. So we need to divide those, and then we can move it and change it into a decimal. Platypus. Oh, you're worried about the platypus. Does he have enough water? Okay, what percentage? That's not a percent. Thank you. There we go. 42% of the tank. So she probably needs to get some more water. Yep. All right, last one in prisms, then we need to move on to cylinders. Surface area of a cube is 150. What is the length of the base edge? When you think, everyone disagree. When you think you know the answer without typing it in the chat, Alex, go ahead and agree, and then we'll go over it. So first period I had students, they didn't know where to start. They were like, there's no cube on my formula chart, I don't know what to do. So what I told them is to start by, okay, this is a work backwards problem. I gave you the surface area. You need to start with the formula. Thank you. You need to start with the formula for surface area. So we go to surface area of a prism. And then you stare at that and you're like, man, I wish they would have just given me the formula for surface area of a cube, right? We need to get creative here because we cannot solve this problem. Can't solve a problem in 3 variables, right? Let's draw a picture. When I don't know what to do, I draw a picture. Do you do that when you get stuck on a problem? Now let's add variables to our picture. What do you want to call a side? Ooh, good thought, Hatham. Sharon wants to call it S. I think she's a little partial because that's what her name is. Let's call one of the sides S. Okay, now let's translate this to the formula on our formula chart because that's all we get on the test. What would P be for this cube? Let's translate it. We just learned what capital P stood for. Ooh, nice. 4S. P is really 4S. What's the height of this cube? Pretend like it looks more cubular than mine. Nice. The height was S. You like this question? Capital B. What did that stand for? It's a new variable. What does it mean? Area of the base. Good. Side squared. Whoa! We just got that down from 3 variables to 1 variable. This is now solvable. Brag. Show off. What's your answer? Ooh, you didn't have it ready. You didn't know how to do it. That's okay. Nice, Hatham. Let's do some algebra and combine like terms. When I was in high school, I memorized this formula. I memorized the surface area and volume of a cube, but it's not on your formula chart, so you need to be careful. 6s squared, that's a thing. That is how you find the surface area of a cube. But you can use pH plus 2b as we just found, but it's a lot more efficient. Like, you know how side squared wasn't on the formula chart? Side squared for a square, but you used it anyway? This is kind of the same thing. All right, so we are doing the inverse of what's being done to S. Oh my goodness, Miss Tanton was nice again. She found a perfect square for you. That's my Monday gift. And the side was 5. 5s always look like S's. I was trying to be intentional. Cool? Can't we? I love how you pointed that out. That's another way to put it. A cylinder sounds like the same definition as a prism. A solid with 2 bases that are congruent, except in this case, the bases are not polygons, the bases are circles. You will have 2 variables when you deal with a cylinder. You'll have an R and an H. So cylinders are a lot less complicated than a prism. A cylinder is a prism with circular bases. We are going to leave our answers in terms of pi unless it's a real-world problem. Let's dive right into the formulas. These are the exact ones on your formula chart. Write them down, please. Lateral area, surface area, and volume. What's really cool is that the formulas are the same for prisms as cylinders. But since a cylinder, we know its base. In a prism, we don't know its base. We're not sure what it's going to be. But in a cylinder, we know its base. But this is really just perimeter times height. Do you see that? It's circumference times height. 2 pi r, that should sound familiar. That's circumference. Yeah. The surface area is circumference times height plus, look at that, that's b, 2b. So it looks just like our prism ones. Pi r squared is just b. And then volume, there's not even a special one for volume on your formula chart. Just base times height. You have to know that the area of the base is where you put the pi r squared. Do these together since we're running out of time. The only thing you could really mess up in this problem is accidentally use the diameter instead of the radius. Let's use the radius, not the diameter. You need an R, you need an H, and then you are in business. So, lateral surface area, 2 pi, skip over the pi. 2 times R times H. And then we will multiply the pi back in. 384 pi. Go ahead and go if you need to. Okay, the total surface area. Don't forget, to find the total surface area, you are going to use some work that you already did. I forgot my fork. Don't recreate the wheel. Use it. Use the one you already created. So it's 2 pi RH, which we already found, plus 2, skip over pi, r squared. So it's 384 plus 2 times 12 squared. You can add them together because they are like terms. They do both have pi in them. So you can add them together to form one term. 672. And my favorite formula, volume, because of its simplicity, base times height. So the base is pi r squared times, not plus, height. So I'm doing 12 squared times 16. Very large volume here. Oops, I was going to do centimeters. Cubic inches. Volume is always cubed. We need to try a work backwards problem. So I gave you the volume of a cylinder. It's 160 pi. If the height is 10, what is the lateral surface area? Whoa, okay. So we have some work to do. The volume is 160 pi. So the volume is that formula right there. Let's get a little bit more specific. The volume is pi r squared h. Oh, we already know h. It's 10. We are looking for r. We're trying to solve for r. Our pi's cancel. I was nice again. Gave you a perfect square. So r squared is 16. And we want the lateral surface area. So we go back to our formula for lateral surface area. It's 2 pi. We just found r. R h. 2 pi RH, 160 times 2. So this one was a multi-step problem. It was a work. Thank you, Ms. Stanton's going crazy. I never square rooted my perfect square. That would help. Let's always square root our perfect square. Thank you. 2 pi RH. There we go. I would love 80 pies right now.